In this video, we are going to discuss about the design for testability. So, on completion of this topic, the students will be able to understand the depth of the fault models, and they can understand the test pattern generation and how the fault is detected based on the designed methods we have been used. So the main outline of this testing is here: logic verification, silicon debug, testing during manufacture, and fault models, observability, controllability, and while designing the test, scanning, built-in self-test, and also boundary scan. First thing, here we are going to see about the testing. So we know the testing is the most expensive part of the chip. That is, this design for chip is a concept, which means that this chip is designed in such a way that testing is easy. So it occurs in two roles. First, it helps the debugging a chip which has design flaws. Second, it can catch the manufacturing problems. So both are particularly important for the ASIC design because of the black box nature of ASICs, where internal nodes are simply not accessible to both the problems. They are applicable to CPLDs as well as FPGAs, but they have already built-in test features. So these allows the better testing of a chip, while not all the techniques need to be included in this design because they are not needed for the testing time or designing time. This DFT techniques are using here in an account to find out the rather that it is very difficult to or it is impossible to test. So one most important consideration is that logic is intended to increase the testability and reliability of the test. So this timing will be fabricated based on the cost, and the shipping parts can be synced based on the company. For example, a logical error not caught until 1 point ship means that is it can be tested based on the reliability of the each chip. And in the logical verification, if the testing logic becomes too large, then it can actually decrease the reliability because the test logics can itself have problems which can cause the chips to malfunction. So the role of this is should not be more than 10 percentage of the logic of the entire chip. Similarly, it should if you spend more than 10 percentage of the time in designing and simulating your test logic independently and the functionality of the chip, then you have more test circuitry than you needed. For example, 32-bit adder, so testing all the combinations of the corner cases as inputs, it requires more time. So good testing requires ingenuity. And silicon debug, so in this silicon debug, this technology has enabled implementation of complex digital system in single chips or reducing the size and power consumption. First, the chip is tested and it is fabricated. If you're lucky, they work on the first time. If not, we have to go to the next process. That is, first one we have going is logical bugs. It can be occurs through the electrical failures. So here mostly the chip failures or logic bugs from the inadequate simulation. Some will be from the electrical failures due to crosstalk, dynamic nodes, and ratio failures. So these methodologies are used here to find out the failure in the failure while designing the chips, and this is how to diagnose the failures. First, it is very hard to access the chips, so we use here pickup props, electron beam, laser voltage probing, and built-in self-test. Also, these plots are very they vary in the voltage and frequency, and they look for cause for the electrical failures. And the next one is manufacturing test. So in this manufacturing test, here this water is sufficient to kill the chip, and this yield should be less than 100 percentage. And mostly this chip testing chips after manufacturing before delivery to the customers is only the good product. So it is very expensive during manufacturing. Time should be very minimized on testing, and careful selection should be taken for testing these vectors. And the next one is testing your chips. So if you don't have any millions of dollars to test, you can build a breadboard with the LEDs and switches, so that you can analyze it logically, and you can generate pattern, or you can use in a low cost functional chip. So major summary of this testing is: think about testing from the beginning, then simulate it and plan the test after fabrication. If you doesn't test it, it doesn't work. So quiz questions: the functions performed during chip testing of what, and delay fault is considered as dash. Thank you.